Okay, so we'll wrap up subsetting. We just had a couple last things to talk about there, and then we'll start getting into programming, flow control loops, all of that kind of stuff. Okay. Right. So let's wrap up. I think we left off here. We said you can do some kind of like a lookup table, and we said, you know, your lookup table can have 3 entries in it, but because subsetting allows you to repeat indices, you could feed in, you know, a vector that's, you know, has 200 things long, is 200 things long, but using the character subsetting there, you can match up, you know, the values in that vector to the values in your lookup table and thus get a match. We're doing effectively the same thing here, except rather than just a simple vector, a named vector as our lookup table, we're using a small data frame, okay? And so when we create this data frame info, you can imagine the row names going 1, 2, 3, but then next to that, the grade goes 3, 2, 1, and then we've got the description, and then whether the person has failed, being false or true, okay? And the grades that we are inputting are 1, 2, 2, 3, and 1, okay? And so here are the grades that, that we look up, and if we use the function match, we get 3, 2, 2, 1, 3. Effectively, what we are doing is we're asking which row corresponds to having a 1. Okay, when we look up grades, we first look up the 1, and then we're asking which row corresponds to info $grade having a 1. Okay, and that's going to say the third row corresponds there. Okay, which row corresponds to having a 2? It's the second row. Okay, and so for each of these, the match looks up which row corresponds to this number. If we had letters, it would do the same thing. Your input would be, you know, characters, and then it would tell you which row corresponds to that. Okay, and then when we use, if we subset just based on this 3, 2, 2, 1, 3, then it produces our table here. It pulls up the third row, then the second row, and because it's pulling up the second row twice, it changes the name to 2.1. Okay, so it adds on this 0.1 to kind of distinguish the fact that it's pulling up the second row again. Okay, because as far as the data frame that it's creating, it's trying to produce unique names. It doesn't mind that you're giving repeat indices here, but when it's naming them, it's going to kind of append these additional characters to it to distinguish it from the other rows. Okay, is that okay? So this is kind of the extended lookup table when you have a data frame to match up with. Okay, and then so there it goes. 3, you know, it pulls this up. All right. We can also select random samples very simply, okay? R has a built-in function called sample. All right, and sample, what that does is it just, if you give it a vector, sample is just going to shuffle those up. If you do replace equals true, then it samples with replacement. But the default behavior of sample is if you say sample 10, it's going to take the integers 1 through 10 and then shuffle them up. So it might go, you know, 5, 7, 2, 1, you know, whatever. It's just going to take whatever integers you give it. So in this case, we have created a data frame with 6 rows. X goes 1, 2, 3, 1, 2, 3. Y goes 6, 5, 4, 3, 2, 1. And the letters go A through F. Okay. And then what we've done, you know, anytime you call the function sample or some kind of random generator thing, it often makes sense to use a set seed for reproducibility. Okay, so if you want to give your code to someone else and say, this is what I've done. If you want them to kind of see the same results that you got, then setting the seed kind of sets the starting point. Okay, because as far as the random number generators go inside the computer, they're not truly random. They behave like random numbers, but it's not truly random. If you start off at one point, the random path that it creates will be the same every single time. For most purposes, it looks very random, but you have the advantage of setting a seed to produce the same results. Okay, so anyway, all we've done is we've just subset the data frame, and then as far as selecting which rows we want, we just said sample number of rows. So basically this is just sample 6 is what we're throwing into selecting the rows that we want. And then when we say sample 6, it has shuffled up the numbers 1 through 6, and the numbers that it produced were 4, 2, 5, 3, 1, 6. And thus, when we sample the 4th row, it pulls up x is 2, y is 3, and z is d. Okay? And then when it selects the 2nd row, it has z is b, and things like that. Okay? So here we've just reshuffled the rows of the data frame. Very simply, with one row, we just said data frame subset, okay, using the single square brackets, and we specify that the rows we want are specified by sample the number of rows. Okay, this is effectively sample 6, which is going to produce a shuffling of the values 1 through 6. Okay. If you only want to select, three random rows, or a subset, not all of them, you can say sample from 6, 3, okay, and then it picks 3 random numbers between 1 and 6. Okay, and then I'm not sure if you've learned bootstrapping. We'll cover bootstrapping briefly later on. You can have another option, replace equals true, which allows you to select kind of the same value more than once. Okay. We saw this maybe briefly before, but if you have some vector, then the order takes the vector and returns an integer vector describing how you should put the values so that the resulting vector will be in order from least to greatest, or in alphabetical order. Okay, so in this case we go BCA, and so the order of this, if you want to put them in order, the first thing should be 3, the second value should be the first item should be the 3rd item, okay, which will be A. The second item should be the first item, which is B, and then the last item should be the second item, which is C. Okay, so it's telling you how, if you want to put X into order, what is the which elements should you pick? You should select the 3rd, then the 1st, then the 2nd. And so if you subset X based on order, you will get A, B, C. Okay. If you want to put them in the reverse order, you can put the option decrease equals true. All right, and by default, any missing values will be put at the end of the vector, but you can get rid of them by saying NA equals last is equal to NA. Or you can put them at the front by doing NA equals last equals false. Okay, that's the other option. So order tells you if you want to arrange the objects in order, what is, how should you subset them? And this gives you the order that you should subset them in. Okay, and it says for 2 or more dimensions, order and integer subsetting makes it easy to order either the rows or columns of an object. Okay, so here I've got, we're going to take our original data frame DF, okay, and then shuffle them up. And we also shuffled up the columns. Okay, so DF2 is all scrambled. Okay, DF2 is all scrambled. but then I'm going to do df2, and we're going to subset it based on the order of x. Okay, we order x, and we get, so we can see that x is now going to be put in order: 1 1 2 2 3 3. Notice we're only ordering based on x, and so it doesn't try to necessarily break ties between column F or column Y. Okay, so coincidentally it goes A, B, C, D over here, but then it doesn't try to put E and F in order here. Okay, because what it sees, it just says, the threes have the threes are tied here, so it doesn't actually care about the ordering there. Okay, and then if we wanted to reorder the columns so that they are in order, we can rearrange the columns and say order the names of the columns X, Y, and Z. Here, this is a common problem that you might get. Okay, sometimes you get a data frame where identical rows have been collapsed into one and a count column has been added. Okay, so rather than having, if we're talking about cars, rather than saying, every observation having its own row, it might just give you a frequency table. Okay, so you might end up getting a frequency table rather than kind of the raw table where every observation has its own row. And perhaps in your calculations or whatnot, you want to expand that frequency table into kind of, so every value has its own entry in the table. Okay, and so we can use subsetting to do something like that. Okay, so here, maybe this is worth exploring in here. Okay, so here I'm producing this data frame. Okay, and so we can see, x has the value 2 and y has the value 9, but apparently this showed up 3 times in our data set. And x has the value 4 and y has the value 11, and this showed up 5 times. And x has value 1 and y has the value 6, and this showed up 1 time. Okay, and it doesn't have to be numeric data. It could be categorical data. It could be a label. It could be whatever it want. The thing is you have a count, okay, like a frequency column that you want to somehow expand. Okay, so what do? We just do repeat, okay, and we say 1 through the number of rows. Okay, so this is going to be just basically 1 through 3 or whatever it is. Okay, and then how much do we repeat? We repeat by the column n. Okay, so effectively I'm just saying repeat the values 1 through 3, and the amount we're repeating is using the column n. Okay, and so what this does is it repeats the value 1 3 times, the value 2 5 times, and the value 3 1 time. Okay, so all I'm just doing is I'm saying repeat 1 through however many rows I have. In this case, I've got 3 rows, and the number that I'm repeating them is based on that frequency column. And then if I take this as input to subset the data frame, okay, again, the data frame doesn't mind that you're giving it repeat indices, and so when it sees 1 1 1, it's going to repeat that entry all 3 times. So here, so I'm basically feeding this part into here, and I'm going data frame bracket subsetting this, okay, and then so it repeats the first row 3 times, it repeats the second row 5 times, and it repeats the third row just 1 time. Okay, and then so yeah, you get these kind of funny row names over here, but you can always get rid of those. And then now that this n column has performed its duty, you can also get rid of it. But the important thing is you wanted these bits of information multiplied, and we have successfully done it. Okay, so for example, I think There used to be a Titanic data set, but I forget what it's called. Maybe it's not called Titanic. But it basically has aggregate data, and sometimes you want it expanded. So doing something like this can be helpful. Okay. And then, and we talked about this, so, if you want to remove a column from a data frame, you just set the column to null. Okay, so if you want to get rid of column Z, you just say $Z is now null. Okay, or you can subset to just return the columns that you want. So if you just say I only want columns X and Y, you can do it that way. So this totally kills it. This creates a copy, and the original data frame still has the original data. Yes?
Certain columns you could also, or could you also put it like
Yeah. So if you subset, you can just say like give me everything other than Z. Yes. You just put the little minus there. Yeah. That's allowed. This method kind of kills that thing in the original data. Okay. Whereas this is you are subsetting and effectively creating a copy. Okay. And so if you store this output in something other than DF, the original data in DF is unchanged, and only where you have stored this is now contains the subset. Okay. Of course, if you subset DF and then overwrite the object's DF, then that old data disappears as well. Okay. There also has some set functions, things like the union and intersection and difference, kind of telling you like which ones are different. And so in this case, you're saying, I want the set of values that are different from Z or something like that. Okay. So I don't know if you guys are familiar with set diff. So if I have, we'll call A will be the letters, will be the first 5 letters of the alphabet, okay, and then we'll have Z be the letters, the 3rd through 8th letters of the alphabet, okay. So A is A through E, and Z is C through H, okay? So set diff is what is different between A and Z, okay? And what is that going to be? It's going to be A, B, and F, G, H. No? I'm sorry. I guess just A, B. I'm sorry. Set diff is just what's in the first that's not in the second. And then, and if you want the other, you do Z and A, okay? And then, and if you want both, then you have to union those. You can, I'm sorry, the other is, I think, exclusive OR. For logical, okay. Okay. I guess you just have to, you'd have to do something like this. Union of set diff A and Z and set diff Z and A. Okay, that's what I originally thought, yeah. So set diff is what's in the first that's not in the second, is what it is. Okay, so these are kind of, you have union, and then you have intersect of A and Z, okay? Things like that. So you can also do union minus the intersection. And yeah, I'm treating these like logical operators, but it doesn't work that way. Okay, so yeah, you have to mess around with kind of these set operators. But as you can see, I'm a little rusty because I don't actually use them very often either. So, but they might be useful at times. So, sorry. Okay. All right, and yeah, we've talked about this, selecting rows based on a condition. You've got some column, and you set it equal. You say, I want the values where it's equal to 5, and you can subset it that way. If you want, so this creates a logical vector of trues and falses, and it returns the vectors where this thing is true. If you have multiple, you can have that, and you just throw in an and symbol, and it means this has to be true, and this statement also has to be true. So then gears will be 5, and cylinders must be 4. Okay, and then of course we have the or operators, and then the not operators to help you with these things. Okay, don't use the double and the double or. Okay, double and, double or is the non-vectorized and or, which means this will only process the first true-false logical comparison there. Okay, so you use the double and, the double or inside if statements, because if statements only allow one true or one false. But if you're trying to subset, use the single and or the single or statement. Okay, we'll take a look at all of this. You got the not symbol and everything like that. You also have the function subset, which is kind of a shorthand for this thing. So if you want to subset empty cars where the column gear is equal to 5, you can do it this way. So you don't have to retype empty cars bracket empty cars $ gear. You can just say subset empty cars where gear is equal to 5, and so on and so forth. So these are options. Later on, we'll cover dplyr, where we have the function filter and all of those things, and I find those are preferable. Okay, we got some Boolean algebra and sets. So set operators are for integer subsetting, Boolean algebra, logical subsetting. So using set operations might be more effective when you want to find things like the first or the last true, or you have very few trues and very many falses or something. A set representation might be faster and require less storage. Otherwise, I think thinking in logical operators of trues and falses is a little bit easier. Earlier, I demonstrated my lack of skill with the set operators, but you can do this. Okay, so you have the which operator. Okay, the which converts from Boolean, the logicals true and falses, into set operators. Okay, basically it just tells you which ones are equal, for which values is this true. Okay, so in sample 10, this just shuffled up the values 1 through 10, and which ones were the ones that are smaller than 4. Okay, it's going to be the values 1, 2, and 3, but those are all mixed up. So it was true for the 2nd, 3rd, and 10th values after we mixed them up. And then which will tell you that you have trues at locations 2, 3, and 10. All right, so over here we can say x1 is basically the even values, right? So it's saying 1 through 10 divided by our modulo operator 2 equal to 0. Okay, so which values divide by 2 evenly? That's going to be the even ones, and so this we get alternating false and true. Okay, and then if I run which on this, it tells me these correspond to 2, 4, 6, 8, 10, which makes sense. Okay, over here I'm going to have y, which is which values are divisible by 5. Okay, and it will tell me 5 and 10. All right, so if I did the and, okay, if I run the and operator on this set of falses and trues, okay, then I get false for everything and it's true for only the 10th value. Okay, I could run which on this and it would give me 10. Another way is I could take the kind of our values, our set operators of 2, 4, 6, 8, 10, and 5 and 10 and ask what's the intersection. Then it will say 10. Over here, I have the the OR, okay, which effectively, when it comes to set operators, is the union operator. So if I say, give me trues for this one or that one being true, then I get this, okay, and then if I do the union, it gives me the set. Okay, but this is not in order, it's just the union set. Okay. Set difference is what is in X that's not in Y. Okay, and so we say X and not Y. Set diff is exactly that. And then over here, the exclusive OR is what's in one but not in the other. Okay, and vice versa. So this is basically everything that appears in only one and only one set. Okay, and that's what we have. We got the set difference of the union of this and this. Okay, I guess that's one way. Or I think I also did union of the set differences, but this works too. Okay. Is this all right? All right. Yeah, this is just talking about subsetting and logical operators and whatnot. No sweat. Okay, that covers subsetting here, and then we'll start going into programming, and we'll see how far we get. Maybe we'll just cover if and else statements here. Okay. Before we get started getting into ifs and elses, you should know where your working directory is, okay? Especially if you're going to be loading up files and whatnot. So our defaults, or our studio defaults to using the location where you have saved your script as the working directory, okay? And I think that's good practice. And so you should make, I would make, for each homework assignment that you're working on, I would make a separate directory for each homework assignment and then put all of the relevant files in that directory, so your working directory is the one that's relevant for that homework, okay? Don't just download the file and then open it directly, because then your downloads folder is going to be your working directory, and everybody knows your downloads folder is this chaotic abyss of stuff. So download it, move it into a proper directory that you've designated for that particular homework assignment, and then open it up there. That should default set your working directory to that directory. You can always check by doing get wd for get your working directory, and then it will show your path, okay? If you're on a Windows machine, the system normally uses backslashes, but those are like escape characters in R, so you either have to double backslash or you've got a forward backslash, okay? You can't specify this, okay? On Unix-based systems, which are your Macs, this will work fine. Okay, I think you guys know how to add comments to your code. You just put the little hash mark there, or you can highlight code and hit Control-Shift-C in RStudio. That's another quick way. You can just whatever you want to turn on and off a comment, highlight it, Control-Shift or Command-Shift-C on your keyboard to take entire chunks of code and either comment or uncomment them. Okay, which is always very useful, because as you're programming, you might have written something and then it doesn't work, but you don't want to throw it away, so you can just comment that chunk away, so that code is still there, but it won't run. Okay, and you should always comment as you're writing stuff, because when because your most important collaborator is yourself, but from like 2 months ago, right? And generally, you have no idea what you were thinking from 2 months ago when you were writing code at 3 in the morning. So, all right, and then clearing your environment. There's a nice little, in RStudio, there's a nice little button, this broom. You can just click that, and it will say, are you sure you want to remove everything? And you can say yes, okay? Or you can just say remove. RM is the way to remove everything, but you can say remove, and you specify list is equal to ls. ls lists all of the objects in your current directory or current global environment, and so ls will list everything off, and then when you remove everything that it lists off, it's going to return back character 0, meaning that I see nothing, I'm giving you back a 0 length character vector. Okay, because normally it gives you a character vector of all of your objects in the global environment. And if you're not in the habit of using scripts, I highly encourage that, especially for anything that's a little bit longer in coding. I would write it as a script and then move it over into your R Markdown notebook, okay? Now I know a lot of times, you know, for shorter things, sure, you can work directly in your R Markdown notebook, but the R Markdown notebooks are not meant for doing kind of heavy lifting and running huge chunks of code, okay? Because every time you knit it, then it just kind of says running code chunk 10 or the code chunk that you've named, and it just kind of goes dot, 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 dot to try to say that it's running that thing. And so, you know, if something goes wrong, you know, it's like you had to wait for all of this other code and all of this computing power just to like lay out the stuff. So if you're working on stuff, I highly recommend working in a script. Once you get it working, then you can move it over into your Markdown notebook. Okay, and then you run things from your script using Command Enter or Control Enter. So those are just some tips. As you do more and more coding, and I don't know how much time you guys spend coding, but as you do more and more, you will pick up and develop your own habits, okay? And I don't want to spend too much time on what good habits are and whatnot, but if you see a lot of coding in your future, you can look up, you know, style guides, which give you tips, so you're not just naming everything, you know, item 1, item 2, item 3, item 4 or something. You know, you'll have at least a good system for naming things. Okay, so let's talk about programming, you know, your ifs and your elses and all of that. And so first we'll start off with the basic logical operators. This is your or, this is and this is not, okay? And these are all vectorized, meaning you can give it a vector of true and false values, another vector of true and false values, and it's able to work with these, okay? It's going to do item by item comparison. The double or, the double and, those are not vectorized, okay? And they serve a purpose when we're throwing them into if statements, okay? And then you've got some kind of other things. You can always ask for help on logic, base logic. All right, the non-vector is preferred in if clauses. That's basically all of it, okay? Numeric vectors will be coerced into logical vectors, where 0 being false and everything that's not 0 will be true, in case you feed in an integer vector. Okay, so here we go. X and Y, we got trues and falses. True, true, false, false for X. False, true, false, true. The ors, if either one is true, return true. So you get true, true, false, true. So it's false only when both are false. Whereas the double or only does it for the first pair. The single and is vectorized. It's only going to return true when both are true, which is the case only for the second pair. So it's going to be false, true, false, false. And then the double and only returns it for the first comparison, true and false, which in this case is false. Exclusive or indicates element-wise exclusive OR, which means true if X or Y is true, but not true if both are true, okay? So this is only one is allowed to be true, not both. Okay, so if we have true, false, then it's true, but if it's true, true, exclusive OR will return false. False, false will say exclusive. Exclusive OR will return false, but then false, true will be true, okay? And then is true only does, yeah, it's an abbreviation for identical, true, and X, okay? So is true will return true if and only if X is, a length 1 logical vector whose element is true and has no attributes. So it has to be the object true. If X is the object true, then this will return true. Otherwise, it's false. This is kind of like maybe just like a little bit of a safety check before you feed something into maybe some kind of if statement or something. I don't use this very often, but it exists. Okay, we've got comparisons for kind of your numeric vectors. Even it applies to character vectors, but character things are a little bit weird. So all right, and all of these are vectorized. Okay. And so you got greater than, less than, greater than or equal to, not equal to. And then for sets, you have kind of this in operator, okay? So is X within some set Y? And that will return true or false if it's able to find a match between the object, the thing X is, and whatever set you're looking for in Y, okay? Which is often very helpful as well. All right, and so when we run things in, create our programs, probably the most common way we control the flow is with if statements, right? We have if some condition, and if that condition is true, then execute the following chunk of code. And if it's not true, then go on. Do not execute this code. And so basically, the code that you want to run, only if it's true, you throw inside a conditional, okay? Curly braces will be used to kind of bracket more than one line of code that applies to the if. Otherwise, if you only have one line, then the line that's immediately after the if will be treated as belonging to the if, okay? So here we go. We have X is the set 1, 3, or not the set, but the vector 1, 3, and we can say is 1 in X, and that's true, okay? And so we say if 1 is in X, then run the code, print hello, and it prints hello, okay? I have no curly braces because there's only one line, okay? So it's just gonna assume that this one line belongs to this if statement. This if statement's gonna evaluate to true, and so it does, it prints hello. Okay. In this case, we say is X greater than or equal to 2, okay? When we ask this question, here we have, we get a vector of false and then true, okay? So if statements only look at one true false value, okay? And if you give it a vector of multiple true false values, this is, it's gonna kick back a warning, and it's only gonna look at the first one, okay? So for here it looks at the false, so it says if, and then X is greater than or equal to 2, it sees a false, so it doesn't bother running this code at all. So it does not execute hello again, so we don't see hello again printed anywhere down here. And it also kicks back a warning. It says the condition has a length greater than 1, and only the first element will be used, okay? So if you want it to say something like, if you want to have the if condition run on all the elements in a vector, you have to put it into a loop and say, look at the first thing, and then run the code accordingly. Look at the second thing, run the code accordingly. Look at the third thing, run the code accordingly. You cannot feed it a vector of trues and falses and expect the if to run in a vectorized form. It's only going to look at the first, and it will kick back a warning if you give it a vector longer than length 1. Okay, so here one option is you can say if any is if any, and you give it a logical vector. So any is basically like the ultimate OR. Okay, so OR is just if at least if you OR is you give it 2 logical values, and if one of those is true, then it will return true. Any is you give it, you know, a vector of length n, and if any one of those is true, then the whole thing will return true. Okay, so that's what any is. Okay, so you could have 9 falses and 1 true, any will return true. So in this case, we've got two logical values, at least one of those is true, and so if we throw that into the if statement, this thing evaluates to true, and it executes the following code. Okay, well, I hate to end here, but I guess we'll end here, okay? So we'll continue on here discussing else statements, okay? And you can expect to see a homework assignment being posted in either tonight or tomorrow, okay? Not due Friday, okay? It'll be due during week 3, okay? And but I want to give it to you guys anyway. So.